Welcome to Properties of Exponents. In today's lesson, we will look at powers of a fraction. Here we have 4 examples. How can you take your knowledge so far of properties of exponents to help you to expand these terms and then to simplify? Pause the video for a second and see if you can figure these out. Remember your definition of exponents. Here we have 2/3 raised to the 3rd power. What does that mean? That means we have 3 of the same factor, 2/3. So one way we can expand this is to say that we have 3 of these. So we have 2/3 times 2/3. Once we have these written out, we simply have a multiplication problem. We have 2 times 2 times 2. And we know that 2 times 2 is 4, and 4 times 2 is 8. On the bottom, we have 3 times 3 times 3. 3 times 3 is 9, and 9 times 3 is 27. Now, how can we simplify this, though, using exponents? How can we write this in another way? Well, if you'll notice, we have 3 2's, 2 times 2 times 2. So we could also write that as 2 to the 3rd power. We also have 3 3's. 3 to the 3rd power. These are equivalent ways of writing the same expression. Now let's analyze the beginning here, 2/3 to the 3rd power, compared to the end, 2 to the 3rd and 3 to the 3rd. Look what we did. We applied the power 3 to both the numerator and the denominator. Let's look at the second one. We have a over b to the 2nd power. So again, we could expand this to help us to understand that we have a over b times another a over b. In this case, a times a we know is a squared, and b times b is b squared. So once again, we took our exponent and we applied it to both the numerator a and the denominator b. Let's expand a little bit and use some of the properties of exponents we learned last week. In this 3rd example, we have a fraction, but notice in the numerator we have a product. We have a product being raised to a power. Pause the video and see if you can figure this out on your own. If we want to start back from scratch and we don't understand it, the best thing is to always expand. So let's first expand with the 3. We know we have 2 times x over y multiplied by 2 times x over y and one more 2 times x over y. We have 3 of them. Now let's count how many factors we have of our common terms here. So we have 2 times x times 2 times x times 2 times x. We could write this like this, 2 times x times 2 times x times 2 times x, and make one big fraction because this is all multiplication. We have y times y times y, so we could write it like this. Then using the commutative property, we could put our 2's together and we could put our x's together like you saw in a previous video. But let's count. We have 1, 2, 3 2's, so that's 2 to the 3rd power. We have 3 x's, so times x to the 3rd power. And on the bottom we have 3 y's, so that's y to the 3rd power. 2 to the 3rd is 2 times 2 times 2, which is just 8, times x to the 3rd over y to the 3rd. Let's look back at our initial problem, and let's compare it to this one right here. We have 2x to the 3rd power. Remember that when we have a product that we're raising to a power, we need to make sure that we apply that power to both terms in this product. So we would have 2 to the 3rd, which is what we have here, and we would have x to the 3rd, which is what we have here. We would then, because we're doing powers of fractions, also need to apply our exponent to our denominator. So now we have y to the third. This is a whole lot simpler than expanding everything out. Let's look at one more example. In this example, you can see on the bottom that we, once again, have a product that we're raising to a power, but then in our numerator we have a power that we're raising to a power. We've done that too. Pause the video and see if you can try this first on your own. In order to help us understand this, again we will go ahead and expand what we have. So I have 3 of these, which means I have x squared over 3y to the 4th 3 times. Now if I wanted to, I could expand this even more. So I have x squared, which means I have x times x. And then times another x squared, which is another x times x. And once again, for the last one, x times x. So I have expanded my numerator completely. I could do the same thing with the denominator. I could expand my y's, but that's going to take a while. So instead for the denominator, let's just count and see what I have. I have 3 3's, so we can write that as 3 to the 3rd power. And then remember what happens when I multiply y to the 4th times y to the 4th times y to the 4th. I have 4 y's here, 4 y's here, and 4 y's here. That's a total of 12 y's. So I'm just going to write that as 12 y's. I could have done that for my x's. I have 2 x's, 2 x's, and 2 x's for a total of 6 x's over 3 to the 3rd times y to the 12th. Once again, let's examine our results and compare them to our original problem. Okay, here's our numerator, x squared. We have to raise that to the 3rd power. Remember, we apply the power to a power. So that's 3 times 2, which gives us the x6. We do the same thing in the denominator. We need to apply the power, though, to each element in our product. So we need to apply the 3 to the other 3. That's 3 to the 3rd power. Then we need to apply the 3 to the y to the 4th. That would be y to the 12th. These are multiplied. So remember, if you're struggling with these, you can always expand them as far as you need to in order to simplify into an exponential expression. So now let's summarize our rule. How do we expand and simplify powers of a fraction? Well, if we have a fraction, we need to apply the exponent to both the numerator and the denominator. So, apply exponent to both the numerator and the denominator. But at this point now, you have many tools in your toolbox for working with properties of exponents, so hopefully you will be able to apply those and not have to expand every time.